Helps when you unmute the mics. Hello and welcome again to Jason Live. My name is Patrick Shea, and we're back to talk once again about careers in science, technology, engineering, and math. It's our STEM career series. And today's guest is Dr. Irina Dolinskaya. Irina is an industrial engineer. She's also a professor of industrial engineering and management sciences at Northwestern University, where she joins us from today. We're going to learn all about Irina and her fascinating career in just a moment. But before we do, I want to remind all of you out there that this event is live and interactive. We're going to be answering your questions, so you can start to send those to us now. Use the box just below this video window to do so. Irina also has a challenge for you today, so we'll be looking for your responses to that too. We'll set that up for you in just a bit, but right now we're going to get Irina involved. Welcome, Irina. Great to have you here today.
Hello, how are you doing?
I'm doing very well. So, before we get started in talking about your work and your personal career, I think we need to talk about what an industrial engineer is, because I'm sure there are kids out there who have heard of other kinds of engineering, say mechanical engineering or electrical or chemical, and even if they don't know exactly what goes on in those fields, they can probably come pretty close to guessing. And I don't think we can just guess what an industrial engineer does. So why don't you start off with telling us what is an industrial engineer?
Well, that's a very good question. You're correct that even I did not know what industrial engineering was until I started my college years. So, industrial engineering focuses on improving things around us. It could be improving efficiency, improving safety of, improving quality, improving profits, fuel consumption. But what's different between industrial engineering and other types of engineering is that we look at the entire system. So, other engineers might be focused on specific components, a specific engine of a car, where what industrial engineers usually do, we have a good understanding of how different parts and different components work enough to understand how they interact with each other. And so we looked at the entire system and trying to see how we can improve the system. And depending on what kinds of system you're looking at, there are different areas of specialization or different focus within industrial engineering. Healthcare, applications, transportation, queuing systems, all kinds of different things depending on what the focus is of the systems that you want to look at. And actually, just let me give you a few examples that actually everyday things that you might relate to and everyday things I use industrial engineering for. So first example is if you're looking at a grocery store and you're interested in checkout line. And there might be different types of lines. There might be an express line where you can only, if you only have 15 items or less, and maybe you have less than 15 items, but you see that the line for those, for that particular checkout lane is too long because there's so many people, have few items and they're very popular. And then there might be self-checkout lines. So deciding, so for you or for me, when I go into the grocery store, I do a little bit of kind of queuing analysis, and this is what I actually teach here at Northwestern, and trying to understand which line do I think will actually get through quicker, and looking, at how fast each person is, each cashier operates, how many items they have in the grocery cart. And so looking at things like that would actually be using some of the industrial engineering techniques. Um, carpool routes, for example, is another option. So for example, this weekend it's your turn to carpool four of your friends to a soccer game, and they might be living four different locations around the neighborhood. Which order should you go pick them up? This is similar to a problem that school buses have to decide in the beginning of the school year. They get information about where different students live in the neighborhood, and they have to come up with the route to actually go and pick up those each student to make sure they're not zigzagging back and forth, which obviously is not going to be as efficient as some of the other routes. Theme parks. Oh, whenever people like going to theme parks with me, because looking at the map and looking at where the popular rides are and knowing how long some of the lines might be, in the beginning of the day, I actually come up with the optimal way to get through the theme park so you can visit as many rides or as many rides that I want to visit as possible. So there you would be using logistics and some of the queuing theory as well from industrial engineering, figure out how to optimally get through the theme park to maximize your satisfaction out of that and fun. Um, you might be running a lemonade stand and you need to decide ahead of time how much sugar to buy, how many lemons to buy. Um, if you buy a big bag of lemons, you might actually get a discount. But if you overestimate how many lemonades, how much you're planning to sell that, the next week, they might actually go bad and you might actually lose money. Or even deciding how to price your lemonade. You might want to look at the weather forecast. And if you know that this weekend is going to be really hot, you might be able to actually increase the price from 50 cents to a dollar and still be able to sell quite a lot of lemonade and improving your profit from that. So different things around you that you might not necessarily think about, but maybe even at as a kid, you're starting to think about, oh, this is not the best way to do things. There might be a better way to do it. If you're starting to think like that, you're an industrial engineer, and as you go through studies, you learn more and more tools that you can actually implement and improve your decisions even more.
Well, I definitely want to go to a theme park with you sometime because I need to optimally get through all of those rides, and I think that would be pretty cool. So let's transition a bit. One of the projects that you work on in putting these kind of systems together is with humanitarian aid. So if you could tell us a little bit about that, and then that's going to lead us into our challenge question for the day. Take it away.
Sure. Well, what so one of my focus area of industrial engineering is logistics and pathfinding. So what I focus on is trying to figure out an optimal way to get somewhere, or when you have multiple locations you want to get there, how to optimally get between them, but actually what order should I visit them as well. And so the challenge that I posted for you today is actually related to this humanitarian logistics setting. So after the disaster, you have supplies positioned at a central point. Let's say that's point A, and you have 3 points of distribution, or maybe three refugee camps where you're trying to distribute the supplies. And those are points B, C, and D. And what you can also see on the graph are the travel times between them. And this is so your objective, your goal is basically go and distribute the supplies to those points as efficiently as possible. These problems are very popular, very common in industrial engineering, especially in a lot of industrial applications and private commercial sectors. If you're thinking about UPS truck delivering packages throughout the day. So a very common objective that first people look at is minimizing travel time. And so that's my first question to you is if I'm leaving, my point A, and I have to come back to point A, visiting all those nodes, what is the path that you would take such that I minimize the total travel time? And then the second challenge is actually something that we have to look at in the humanitarian logistics setting. We don't always want to minimize total travel time. Sometimes some other things such as urgency is more important. So the second question that I want you to look at is how would your route change, or what path would you choose if your objective to actually is minimize the last arrival? So try to get to the last person that gets the supplies as early as possible, but you have to still deliver supplies to everyone. So that's my challenge for you, and I will look forward to hearing your answers.
Yep. So you guys have that image down below the video window in our interactivity box, and just put your solutions to that into the response where you type in a question, and we'll talk about those a little bit later in the program. So, Irina, this is a starter, a beginner's kind of a problem, I would think, and the challenges that you're faced with are probably a lot more complex than this. So, talk to me about what some of those are and what kind of tools you use to tackle them.
For example, let's continue with the humanitarian logistics application that I'm working on. A lot of things. So, first of all, we use a lot of math. So for those of you who are right now taking math in middle school and high school and you think that there's really not much use to that, hold on and just wait a couple more years. I promise you'll see all kinds of different applications to that. So a lot of what I do is actually using mathematical equations, trying to write equations to represent what actually happens in real life, and then using different mathematical techniques to solve them, and often using computer programs to solve them as well. So part of my job is actually to code up and write up the algorithms to actually solve the problems with that come up from real life. Um,
And
so
these real life problems, I think it's important to kind of emphasize this point. You're using math to save people's lives, essentially.
Absolutely. So let me tell you a little bit about a project that we are working on in humanitarian logistics, which is focusing on improving search and rescue operations right after the disaster. And our goal is to look at how we can use real-time information from crowdsourced data, such as people tweeting about it or maybe texting, how we can use that information to help search and rescue teams on the ground. So, for example, what you can see right now on the screen, right after Haiti earthquake in 2010, they set up a texting system where people could text from their regular cell phones information such as they need help, somebody is trapped, or maybe a bridge is out, or building collapsed. And we collected all those texts, and they were translated to English right away on the spot, and then basically relayed back to the people on the ground with the important information to help them the operations. So what we're looking at right now is how to make it more systematically, um, to use those texts, and also how to actually use that information in my logistics distribution type of problems that we're trying to solve, not necessarily just search and rescue. But there's a lot of technology out there right now that is making it possible for us to collect real-time data, to have this information, especially after disaster setting. It's such a chaotic environment that it's hard for somebody to go and systematically learn things, or maybe sometimes disasters happen in the areas where Google Maps are not as up to date as you might think, uh, is in other parts. So we are really relying on information coming in very, real time. From different sources. So, for example, what you can see on the screen right now, this is the map, the most current map that they had on the left right before the disaster. As you can imagine, before that, very few people in that area were actually using technology and Google Maps to get to their neighbors or their friends' area. So there was not a lot of data available to the broader community. So right after the earthquake, all these people were coming in from other parts of the world to help in relief, but they had very little information about the logistics and the infrastructure there. So on the right, you can see a picture of actually people. There's there's this website OpenStreetMap where people can go in, and anybody, you and me, can go and update map information that we know. And so if everybody goes and updates a little bit of information about their neighborhood, then together when we put it all into one map, we have a map of the whole world. And so how do you use this real time updating map into your mathematical equations, because they have to account for the fact that new data keeps coming in, and how you actually decide to make better logistical decisions, search and rescue operations, distributing supplies.
So you've got another really interesting project that you were telling me about the other day involving Navy ships. What's going on with that? How do you apply
So
industrial engineering to
another big
Navy?
project I've been working on is actually a collaboration with my colleagues from University of Michigan Naval Architecture and Marine Engineering Department. Basically, they're the ship and waves experts, and what they're developing is innovative this new radar that is mounted on the ship, and it can in real time see each individual wave surrounding the vessel. And so then they use physics and all this other science about the waves movement, that they can actually create a movie of predicting how the waves going to change over time. And then my job is actually use this real-time information to navigate vessels through this stormy waves. So here you can see an example of what the simulation of the waves would look like. And my goal is to come up with basically a GPS-like system where I navigate through the waves and trying to get to the destination. And I might have different objectives. Sometimes I want to get to destination as quickly as possible, but often, especially in Navy applications, um, problems such as Navy rescue missions, for example, in a high stormy setting would be of interest to them. So a lot of times my objective is actually to find a path to make sure that the ship doesn't capsize, or how do you actually safely get through the waves, because often they don't have a choice of just waiting for the calmer weather to come along. But it's very similar, if you think about it, to some of the humanitarian work I was just telling you about, because you once again have this real time information coming in to you, and you have to in real time make decisions how to actually change your route. So you might have already similar experience with GPS systems when you can see traffic update on the in your area, but now we're looking at other settings where it's not as easy to collect the data, but it's very crucial to have the data. And Navy applications and just trying to get through a very stormy environment is one of those examples. Post-disaster relief distribution or search and rescue operations is another example. So while the applications are different, the math behind it is actually quite similar.
That's really interesting. We've got some questions coming in from our audience, and we're going to start to take a few of those now. This first one is from Liam. He says, how many different projects do you do in a year?
I do quite a few because I actually don't necessarily complete the whole project in 1 year. So at any given time, I might be working somewhere between 4 to 6 projects, but it doesn't mean I actually get them all done in 1 year, because most of these projects, as you can imagine, are very massive projects, involve working with a lot of other people. So it kind of takes multiple years to complete a project.
We've got a question now from Mitchell. He wants to know what's the difference between industrial engineering and supply chain management?
Wow, that's a very smart kid. Supply chain management is actually part of industrial engineering. So as an industrial engineer, you could be looking at supply chain management problems. And just to give a bit of a background for everyone else, supply chain management is looking at how, for example, a retail store like Amazon, for example, or Target or Walmart would decide of how to distribute their supplies, how much to order, where to position the warehouses, and then how to distribute them to the customers. So actually supply chain management is something that we do in one of the classes that we teach in our department.
Famous industrial engineer, supply chain management expert, Tim Cook, now CEO of Apple.
There you
So
go.
there you go. We've got more questions coming in. I'm not sure if you're going to be able to see this one, but I'll read it out for you. This is from Kaylee. What's the most difficult job or project you've ever done?
It depends on how you define difficult. I mean, all of them are very challenging. The exciting part and the challenging part of a researcher like me is that we work on the problems that haven't been solved before. So it's not like you can look up the answer at the end of the book, um, or what formula to plug in to solve something. So I would say all of the projects are challenging, and the challenge really comes from the fact that you don't really know what tool to use or what the solution will look like until trying out a lot of different things and figuring out what actually works.
Okay, here's another tough question. This was a combo from Lorenzo, Kaylee, and Mitchell. Do you like your job now? What's the best part of your job? And what do you like the most about your job?
Well, thank you guys for teaming up. Teamwork is very important in industrial engineering. Um, I really I love my job, and I think the part that there's so many components that are fun of it. I get to teach students. That's something that I was passionate since I was a kid. When I was a kid, I wanted to be a math teacher because at that time math was kind of my favorite subject, and I didn't know that there's so much more you could do with math. But I really wanted to teach. But you can also pick your own projects that you work on. Nobody tells you you have to work on this specific project. Um, Being a professor, research professor like me, I get to pick and choose what projects I do. And I think the fun part is you get to work with a lot of people. You get to work with students, you get to work with clients or people in the field that might be using your techniques, or you're trying to solve their problems. Um, and no 2 days are the same. It's just so much fun because every day I get to do different things. Some days I go to teach, some days I work on the problems. Um, just some days I have to sit and write a paper, write a proposal, or go to a conference. So there's just so much to do that it would be hard to pick one.
So we're going to shift gears a little bit and start to talk about how you got into the career that you're in now. So your career path. We've got a question here from Paige that's going to start to take us in that direction. She wants to know, was it hard for you to learn how to do what you do, and who helped you?
Um, it's definitely it, it was definitely a challenge, but I think that's what was really attracting me to this position. I like challenges. If you put a challenge in front of me, I want to prove everyone wrong that and say, no, I can definitely do it. And that's what I think drives me, and that's what excites me. And I, I really had to go through, kind of schooling. So I went to, after finishing high school, I went to college, and I did my undergraduate in industrial engineering. And then, so this is the Bachelor of Science, the degree that most people get when they go to college. But after that, I decided that I wanted to learn a little bit more about industrial engineering. And so I went on to graduate school. And so it was another 5 years for me to get a master's and a doctorate degree to finally become a professor. But the doctorate degree is really needed to be a professor. You don't need it if you want to just be industrial engineer and actually go and work for companies or for different organizations to actually improve their things and kind of work, on their on supply chain management companies, consulting companies. For that, you really only need to go to school for the first 4 years, and if you want to get a master's, you can do that as well.
We've got a fun question here. So I know in your career profile that we posted online, you had mentioned that your mom, who is an accountant, wanted you to be an accountant. This question's related to that. It's from Emily. She says, "Could you imagine now being an accountant? Would you be as happy as you are now, or would you rather have done that?"
Uh, so I guess I can imagine myself being an accountant. I do kind of personal accounting in my family, my personal finance, because I still like accounting as part of it. But I feel like there's so many different things that I do now as a professor, as a researcher, that there's more diversity of things that I get to do, and that's the part that really attracts me. So with accounting, maybe I don't know if you get different clients, maybe you get a lot of diversity as well. But I'm very happy with the way that things worked out right now.
Great. We've got another career path question here. This one's from Alicia and Jess, and they want to know, how did your career start out?
We
So I guess once you've decided that you wanted to be an industrial engineer and you went and took the classes, you got your degrees, what happens next? How do you really kick into the point where you are a professional industrial engineer?
Well, the great thing is that during your college experience, you actually get to work on a lot of projects while in school. And in fact, all our engineers during their senior year in college, they have to work on a real project with real company. So that really eases you in. I understand where the question is coming from. When I was in college, first couple of years, I thought, how would anybody pay me real money to do this day in and day out? But as you go through the studies, you get to do a lot of projects, and that gets you, you get a little bit more confident that, oh wow, everything I learned can actually be applied, and I can actually help these companies, save money or improve the safety or other aspect of their operation. So that really kind of helps you a little bit not be as intimidated the day one of your work, because you've done those things. And a lot of students also do something called internships, where over the summer they get to actually go to a real company and work for 3 months or 4 months at a real company using what you learn in school. And I've done one of those as well. So that's really helped me, and I think helps most students transition from just being a student to being, a real job.
Okay, we've got one last question in this section. This was from Garrett. He wants to know what your favorite subject was in school. And I'm going to have you go all the way back to middle school.
Okay.
Was it science, math, English, reading, etc.? Garrett wants to know.
Um, I was not really good at literature and reading part and English. I math was I liked math, and I liked physics. Physics was another course that I really enjoyed. Um, because I was not very good at memorizing things. So things like learning a foreign language or biology, where you have to memorize a lot of terms, were really difficult for me. I like the things with formulas, because there, if you really understand why, you can, formula makes sense, and it's very easy for you to know exactly what it stands for. And if you don't remember it, you can kind of almost come up with it because you understand why things happen. So those were my favorite subjects, the one that did not require memorization.
Cool. We have to get moving along here, and I want to swing back around to the challenge that you posed earlier.
Yes.
Um, Kids out there have been thinking about it, and they're wondering what the right solution is. So why don't you talk us through um, this next aspect of the challenge?
Okay. So again, I wanted to highlight the one of the key kind of important components of this. I wanted to show that depending on what your goal is, your path might actually look very different. So in the first challenge, I asked you what path would you take to minimize total travel time? And you can see solution over here is going from A to B, B, D to C, and then back to A. Or you can go the other way around. That's also correct answer. Often there are more than one correct answer in real life. So either one of those will get you the shortest path. But what important thing to note here is that the last node that you arrive to, node C, has to wait until 6 p.m. to get their supplies. And that might not be actually a good thing, because if they're waiting for that, life-saving medication or food, you might be able to do better. So in the second part of the challenge, we looked at what if I want to minimize latest arrival. And here the answer is A, B, B, C, C, D, and then back to A. So you can see here that you would actually get to your last node that you go to visit at 2 p.m. So that's 4 hours that could actually make a lot of difference from distributing, getting their supplies or their food. However, your overall travel time is 22 hours. So it really depends. So you will, consume more gasoline and things like that to do that route. So the question you should ask yourself in different problems, especially humanitarian logistic, is what is your goal? What should be your objective? And it depends on what you're actually trying to accomplish.
Great, thanks for that. And again, this is a pretty simple example, but if you had, 30 sites that had to receive, that's a lot harder to do um, if you're just kind of doing it with pen and paper. That's where uh, your algorithms and your computer coding and your math would kick into play, correct?
Absolutely, yes. I do. If you're really curious, go home, try 15 nodes and figure out. It will take you at least all night.
So we had a question earlier from one of our guests. They wanted to know what's the fastest route planning that you've ever been able to do?
How fast?
Yeah, what's the shortest amount of time
Oh,
for an example like
I
that?
specialize in writing computer programs that actually have to do it very quickly. So we're talking about seconds, if less than a second, because
Hmm.
you have to do it very quickly. If you're going up that wave, you can't take it too long to figure out where to go to next.
Okay, we've got another question. It just came in from Olivia. What tips do you have for people who want to follow in your path and get this kind of industrial engineering job? And it just disappeared, but that's okay because I have the rest
Um,
of the question here. Besides being excellent at math, what other skills are good to have for that kind of role?
a lot of it is puzzle solving, kind of not just straight math, but you have to figure out, and, you know, you have to be creative. As I said, a lot of problems I'm working on, there are no solutions that are out there. So you have to be creative on what kind of things you've done. So one of the things I'm actually like to do a lot of art and, creative side. I went to a number of years to the art school actually to get some of that as well. I'm not sure how much it helps me, but I think being creative, just being, also very curious about things. When you see something, when you're standing in line for too long in a, a bank or in cafeteria in your school, do you sometimes ask yourself, why is that the case? Can you do better than that? So being curious about things, and I guess passionate about trying to improve things and try to make things better. Um, that might be a bit too vague, but
We're starting to
that's the
run,
answer.
yeah, we're starting to run low on time. So I did want to have a little bit of a chance to get to know, Irina outside of work. And you just mentioned taking some art classes. What other kinds of things do you like to do in your free time?
I like to go swimming. That's how I exercise and helps me think about the next research project I'm working on. I actually have done martial arts for quite a while when I was a kid and then later in college. I like to do a lot of arts and ceramics and things like that. A lot of crochet. Oh, this is actually, yes, this is one of the ceramics I've done. I've made. This is a gator from University of Florida, which is where I went to college. Um, I also enjoy cooking and traveling. The great part about my job is that there are conferences all around the world that you get to travel different places and you get to meet. So this is a conference in Italy. Um, there are a lot of things that, knitting, crochet is another things that I really enjoy. Making clothes for my son and things like that.
And finding the quickest path through theme parks, of course. Yep.
Yes.
All
You're
right.
welcome to come to my next theme park adventure with me.
I'm looking forward to it. Well, unfortunately, that is all the time we have. Can you believe it? Went really fast. I want to thank you for joining us today. We learned a lot, and we wish you best of luck in your future career.
Thank you for having me.
All right. Um, we've got a few more things to chat about before we wrap up here. Um, we have a number of contests going on with Jason right now. And there's not one, not two, but actually three art contests going on at the same time. The first focuses on cell phone recycling awareness. The second's theme is sustainable seas. And the third challenge you to design the next expedition patch for the EV Nautilus. So go to jason.org/contests and enter to win some really cool prizes in those contests. And we also have another live event coming up next week. It's on Halloween. It's with geochemist Katie Inderbitson. And since it does fall on Halloween, we're looking for video question submissions with students in costume. So put on a great costume, ask a great question, send us the video before the event, and we could see your face in our next event. That is it for today for Jason Live. I'm Patrick Shea. We thank you for joining. We'll see you next time. Take care.